Take the ultimate trip, a journey through time. Blast far into the future. Leap back to the past. Scientists thought it couldn't be done, but maybe they were wrong. Imagine the thrill of the ultimate adventure. A journey far into the future. Or tour the ancient past.
Think about it. You could go back billions of years and see the solar system form. You could see life begin on Earth. You could see the pyramids being built. You could visit the crucifixion.
It used to be considered pure fantasy, but remarkable developments in science are bringing us closer than ever to pushing through the barriers of time. Leaping from one century to another, from anywhere to any when. It's something most scientists argued could never be done. But others clung to the dream and continued searching for ways to somehow, someday, break the barriers of time.
It's a feedback between science fiction and science reality. Almost anything you can imagine in science fiction, it's starting to come true today.
One scientist claims he's already made music time travel, giving new hope that we too may one day take that journey. Every hour of every day we push the limits of time and space. Racing the clock to break one record after another. Testing ourselves against the seconds, the milliseconds, the femtoseconds. Experience tells us that time and space are linked to speed. For example, flying rather than driving from Los Angeles to New York cuts traveling time from days to hours. The increase in speed allowed more space to be crossed in less time. These air travelers may not know it, but they're about to take a voyage into the future. The faster they fly, the slower their watches tick compared to clocks on the ground. Even at these speeds, the difference amounts to no more than the tiniest fraction of a second. When they land, they have jumped imperceptibly forward in time. This phenomenon was predicted by Albert Einstein more than 80 years ago. His calculations show that time flows more slowly for someone moving at high speed than for someone standing still. It's this relative difference in the flow of time that causes all airline passengers to jump fractionally forward into the future. This effect is called time dilation. It sounds truly strange, and the faster you go, the stranger it gets. Suppose there are identical twins, one named Ted and the other named Bob. Bob joins a very fast starship and zooms into space, leaving his brother on Earth. Because he's traveling so fast, and clocks on the spaceship are recording time slowly relative to clocks back on Earth, Bob is stretching the age difference between himself and his twin. After a 2-year journey, this would be his calculation of how large that time gap had become.
I'm 2 years older, and my poor brother Ted has aged 140 years. It's as if you hopped in your almost at the speed of light spaceship when Benjamin Franklin was just a young boy. And now you're coming back after aging only 4 years, just barely in time for the turn of the millennium parties.
Solid rocket ignition and liftoff.
Because spacecraft travel much faster than passenger planes, the time dilation effect is greater. For example, astronauts on board the space shuttle orbit the Earth at more than 17,000 miles an hour. If they were to stay in space for a full year, when they returned home, they would have jumped 3.8 seconds into the future in Earth time. Much faster travel would cause them to jump much further ahead. But if going forward in time is as simple as building faster spacecraft, why aren't we designing them now? The fact is, in order to gain any big jump on time, we need to travel thousands of times faster than even our fastest spacecraft can carry us. If the shuttle could travel 4,000 times quicker, astronauts could leap more than 60,000 years forward in time. NASA already has super-fast rockets on the drawing board, but the most powerful will still only drive us at 25 miles a second. Nowhere near fast enough to make a big jump into the future. Despite the difficulties we may face in trying to achieve ultra-high speeds, physicist Dr. Jack Sarfati believes we must take up the challenge.
So let's do it. Let's get ready. The monolith is here. It's all. Let's get ready for the big trip into the 21st century and out into space. Let's make Star Trek real.
To do that, we have to break some seemingly insurmountable barriers.
This airplane and this pilot are about to be the first ever to fly faster than the speed of sound in level flight.
50 years ago, American pilot Chuck Yeager became the first person to fly faster than the speed of sound.
In level flight will be a really big moment.
Yeager proved that the sound barrier was not a physical limit, merely an imaginary one.
In the Smithsonian Institution.
But beyond the sound barrier is a theoretically unbeatable barrier. The light barrier is where things get really weird. If we move faster and closer to the speed of light, we jump further forward in time. But if we could somehow travel faster than the speed of light, then in theory, we go backwards in time. In other words, imagine traveling as fast as a speeding bullet. Superheroes beware. As we accelerate to catch up with a bullet, time dilation would begin to occur. But when we reach the same speed as the bullet itself, it would seem to stop in midair, because time is flowing at the same rate for it and us. If we could eventually overtake the speed of light itself, then time would flow backwards. The world would become a mysterious place as everything went into reverse. Though the laws of physics say we can never travel faster than the speed of light, there may be scientific loopholes that allow us to travel back in time.
For years we've been told you can't do that. There's no way to do it. Now we're starting to get theoretical models that say, wait a minute, yes you can do that.